Welcome to R3GEN Coding. Thank you so much for stopping by. We're going to talk about arrays and data type limits and things like that. So array limits and data type limits. Why those two specifically? Well, I just realized that I was like copying over arrays, and I haven't even talked to you about the dangers of exceeding an array value. It's not really dangerous. It just means the program's going to crash. Anytime I talk about dangers, it's just going to be mainly the program's going to crash or you're going to alter data. So for the most part, when you're testing your programs, you don't want to use documents that you plan on finalizing. I had one student. I had one student. I was working with a student once who we were doing the C++ graphics application design, and what the teacher was trying to impose to us throughout the whole curriculum was, hey, why wouldn't you just move everything where you need to have it, program your program to save everything by the push of a button, and then remove that functionality afterwards, and then reload everything using the text data you just saved it all to. Um, a lot of us students really liked that idea. At least the student I was working with, he liked that idea so much he just kept doing it over and over and over again. Eventually, he actually rewrote all of his progress. Did nothing. Like he made a typo in his program, and after he got everything set up, he went to save it, and when it saved, there was something wrong with the logic that sent it to the file. I don't know exactly what it was, but he's just like, "Oh man, everything's gone." That's the danger. You don't want to use actual working files, obviously, to be testing your software. You want to be using brand new blank documents. You want to be using stuff that doesn't matter. So that's why, yeah, these programs that I'm building, these are purely conceptual. They've got no ties to anything. Play with them as much as you want. But here we have the representations right here. The max value in C sharp, it's like a property. It's a public property of a uint data type. It looks like it's pretty static too. It's a constant. Um, I can tell you it's static because we're calling upon it using the data type. We're not instantiating the data type and then going largest possible integer dot max value. So I can tell you it's a static constant that is represented by um, how many numbers can be represented by 32 bits. 1, 2, 3, 4. Oh, 32. What is? One second. I gotta pull out a calculator. I usually have the computer do the math for me, and I don't have to worry so much about it. But. Okay. So a int and a uint, they both represent um numbers using 32 bits. However, a uint there. All right. So in an int, all of these bits, and this is all in memory, and this is all conceptual. Keep that in mind. So you just have to. This is what people think makes programming hard. It's not. It's just following through the logic without actually knowing the path, without actually like following Riding Hood herself. It's hard to kind of see where the logic broke. That's the main issue with programming. But this stuff's actually like, as long as you just keep it conceptual, as long as you just understand, oh, okay, so there's bits I need to reserve. As long as I don't exceed my allowance, I'm fine. Um, but each one of these spaces represents on and off. All right, and that's how computers represent numbers: on or it's off. And it represents them by bits. In an int, all these bits that I've highlighted right now are reserved for number values. In an uint, it knows that it's going to be unsigned, so it doesn't bother reserving that single bit there to be positive or negative. It gives it to the numbers. So how does that provide double the amount of space? It's actually quite simple. The because it's binary, we're only looking at ones or zeros, the answer could only ever be 1 and 0. So let's just look at 1, 2, and 3 represented in binary. I'm not going to use integers, all right? I'm going to use something probably close to a short, which is half that to represent that. So we're going to represent 1, 2, and 3 with bits. This is 1. This is 2. I know you probably already know where I'm going with this. Just bear with me. And that's 3. Okay. But do you see how it's like only ones that I'm actually inputting? So like the way you have to kind of understand this is this section represents a 1 if it's on. This section represents a 2 if it's on. This section represents a 4 if it's on. This section represents an 8 if it's on. And if you think about it logically, 4 plus 2 plus 1, we're looking at 7. So then all those bits would go off, and then this bit would go on for the next representation, which would be 8. And if you keep following that pattern, you'll find that eventually, this right here, that is the largest possible representation without using that very first bit. Because that very first bit's reserved for positive or negative sign. Whereas in a uint, we know it's unsigned. That bit does not need to be reserved. We can use that extra bit to represent the second binary representation. Sorry, the double the binary representation. So yeah, anything binary representation, if you're going up a stage, it's twice. It's a factor of 2. It's a, how do they call it? It's exponents essentially. So you're looking at and this is highly technical and boring. No one wants to care about this. I'll move forward, but this is significant to understand. That every data type will probably have a signed and an unsigned representation of it, and knowing how we were actually getting twice the value is going to help you understand how you're going to program. And it's going to help you in the long run save memory, because if you find like you're using ints and it's not working, so you decide to use longs instead, you're effectively doubling the reserve for um each variable that you're reserving for an int, that you were reserving for an int into a long. You'd be much better if you weren't using any negatives whatsoever to switch to a ulong. Sorry, a uint. And same thing goes for longs. If you really want to get that ridiculously high number to use all 64 bits for positive numbers, this is arcade games. There are other ways to facilitate that as well, converting it to string back to. I'm not going to get into that. There's a whole library from the Boost library system that composes libraries for C++. They have a CPP int. That much I know of. I'm not too certain about C#. I can get back to you on that one. But the CPP int can represent pretty much any possible number that you want, regardless of memory allocation, and it does some weird conversions back and forth to be able to do it. And you can use them as if you're using any standard integer value. But you do have to have your library imported. And if you are submitting it for an assignment and your teacher, which is apparently this is pretty common, doesn't know as well with C++, like they understand object oriented enough to be able to mark. But they haven't imported the Boost library because they're not about that. Yeah, it doesn't matter. They my teachers have been super understanding anyways. I can be 100% honest about that. I did submit a couple libraries that they didn't have on their computer. They just told me to resubmit it. It wasn't a problem. I thought that they had a Boost library, but I could have, you know what? It's something like that. It could have been linked to the project differently than where it was in there. So moving forward, we're gonna go with the ulong, largest possible ulong right here. Let me get on my socials here because yeah, my viewership is killing me here. Don't mind me. I apologize. This constant breaking, to be honest. let me, I don't need edge. Use that to troubleshoot. You know what? I'm gonna put some music on for you, and I'm gonna put a be right back sign because, yeah, it's gonna be more appropriate. I am gonna be right back. Thank you so much for patiently waiting. We'll be right back after these short messages. Thank you so much. Thank you again for patiently waiting. All right, so I did manage to send all that off. I'm going to worry about that. Okay, we're gonna move on. Um, so basically, yeah, if you continue down this lineup, you can easily see how um, using hiding that number actually reduces the values by half, as all of these numbers will only be able to represent a single number less than what that single bit can represent, if that makes sense. So yeah, U putting the U in front of your data type is going to extend the amount of bits it reserves. Sorry, not the bits it reserves, or is going to extend the amount of values, positive values it can represent. Yeah, and if you go negative, this will throw this. This will crash the program if you try to throw a negative. And this is just me filling an array, and then basically, actually, here, hold on. I'm not gonna bother with string manipulation. I'm just gonna make it readable. You can see here I'm just basically adding some text to show what these values represent. So basically, yeah, with this program, I simply go, okay, um, I could do this, or I could contain everything in an array and then loop through the array to iterate it. And then over here, I just basically instantiate an array of 10, and then I put 11 in. Oh, well, okay. That's why. I'm gonna keep that anyways because that is actually 10 digits. It's 0 through 9. Um, yeah, it's the same kind of idea, but the um, yeah, it's a weird updating thing. Anyways, so with the array of 10, we go through numbers 0 through 9, assign them to that array. And this is essentially where I would be like, oh, okay, so now what happens if we leave the bounds of the array? Well, we throw an exception right here. This exception looks familiar. The exception looks similar to the one that we kept running into with our sorting example. This is why I kind of rushed the sorting example. I don't know why I rushed the sorting example. I should have went through all this stuff first. But yeah, so as you can see, huh, okay. Anyways, you see it went outside of the bounds of the array. And what it means by that is it's trying to access the value at location 10. There is no location 10. There's only strings 0 through 9. So there's no memory location 10. There's 10 memory locations, but 0 through 9 compensates the 10. So that's why you can't do it equal to the length. You do it equal to the length right here. then you're asking for a value that doesn't exist. You could do it equal to length subtract 1, but, like, I mean, why? Have it less than. Sorry, don't let it run unless, sorry, yeah, don't let it run unless I is less than the length, then that will always be fine as well. So, yeah, this assigns a value, and then this writes all the lines, right? And then right lines puts another line there after it all. And yeah. So we learned why this is we've learned why this is possible. We've learned why this is possible, yet this cannot be. Um in the first half hour of the stream. Okay. I might go for a quick break just so I can come back. And instead of just saying, well, I'm gonna start working on my own projects. If you guys want to ask questions, go ahead. I'm gonna take a quick break so I can add to this lesson. Um Apologize for that, folks. I'll be right back in a minute. Thank you so much for tuning in. We are coming back. Welcome back. We are actually going to start coding design patterns. Thinking it's either going to be design patterns. Yeah. That's. Oh, you know what? Let's code a binary tree. I haven't done that in a little while. If we code a binary tree, last time I did that was in C++, so I don't know how this is going to work out. Um, but yeah, last time I coded a binary tree was in C++, and that really kind of opened up my eyes to understand how we're actually object constructing. When you code a binary tree, I was thinking to myself like a decision tree. It literally just formed the logic for it. But no, they what they actually expect, what the college would expect you to do at that level, is to compose like node style structs, node style objects, um, and have them connected through pointers, and that's essentially pull up paint again. You know what? We're just gonna start a new paint because this is no wait. I don't want to save it. New, don't save. All right, so if we open up Paint again, if we look at a decision tree, we have circle. And let's just say that circle is going to lead to two options. And each one of these circles leads to two options. But one of these options is already at the bottom, so we're going to continue down the stretch where this one actually leads to two more options. And then maybe this one leads to another one. This one's going to lead to two more options as well. So it's going to lead to two more options. And then that's all going to be the bottom. Because it really doesn't, this is just representation. We're going to go draw our connections. And the pointers themselves are the ones simulating these lines. If that makes sense. So when you'd have this object, you'd basically look at this object here. Give me an arrow, actually. There, that's nicer. And within that object, you're going to store these things called in C++, you'd call them node pointers. All right, so this is kind of what would be embodied in that roughly. Usually you have, let's see if I can tab this without, yeah, okay, it's gonna, all right. So usually you have some kind of, in a decision tree, you're trying to code out options based on whatever example slips into the tree. So if you're passing an object to the decision tree, that decision tree is going to compare that object's data to the node that it's currently on and then send it on a way, either left or right path, um, given the option. And like the objects that you're going to pass through, they should contain a node pointer as well. Because that node pointer is just going to simulate exactly where they are along the tree. Yeah. So this is purely conceptual. What it's going to look like um, in code, we're going to go that's our end goal. The whole binary decision tree to be coded out. Okay. Can I just like up your text? Oh, here it is. Sorry. If Paint crashes on my computer, I gotta boycott Windows 11. I swear. My printer drivers have been acting funny. Yeah, everything's just messed up. Anyways, so our binary decision tree. Move this up out of the way. We'll refer to that if we need to later on. By the way, if you haven't already, hit the like, hit the subscribe, hit the share button. Sorry about that. I'm not gonna put the decision tree in here because it's gonna take me too long to notate it, and that I plan on having uploaded, just after I get off. Really, I'm gonna like I don't have a whole lot more notes to go through. Okay. So that I'm just gonna push that out of the way. There's really nothing left on that. All right. So with this. Yeah, so I ended up moving this because this memento is not actually an accurate representation of a memento. I did like it performs what a memento should perform, but it doesn't do the it doesn't have the protection level a memento should. A memento should only be able to be extracted from the object that it originally created it. So it's just a matter of refactoring, moving some of the classes that I've created into other classes and changing the oh changing the access modifier that be the private protected public delegation at the very front. Um so I'm gonna fix that before I do upload this, and I'm just kind of moving programs back and forth out of this. But so this is the program that I'm gonna actually go ahead and create a new decision tree, new project. C# console app. Cool. I'm gonna go ahead and update some of my stuff here too. By the way, because we're now doing decision tree. I didn't actually change this. Oh my word! I'm sorry. And that's where I messed up. I'm sorry. I didn't update. I didn't update Streamlabs. Let me just finish doing this. I apologize. I'll just copy that. Oh, yeah, I think I copied it. Paste. Cool. Update. All right, so we're just gonna send all the updates out. Cool, cool. So we should be updated now. Should be good to go. Let me just double check here. Facebook says we're updated. We got that's actually fine like that. And Twitch. Because I forgot to sign in completely. But yeah, moving towards our decision tree, we're actually so I feel confident that whoever's watching this, if they have seen the previous recordings, they're going to be able to follow along with this relatively easily. I found the decision tree was hard to grasp when I wasn't conceptualizing it properly in my head, and I just wrote logic for it. What I wasn't doing, and you can hear everything. No, you can't because I shut off desktop. Um, I just had a hard time conceptualizing it as like as an actual structure. Um, but yeah, it for sure is an actual structure. Who can I promote? Here, you know what? Got one viewer. It's probably me. Purple Cow. He's live right now. He's playing Elden Ring. He's doing a no death run. Guy I've been following for quite some time. He doesn't even need me lurking, but I'm gonna lurk anyways because I'd like to see his content while I'm streaming myself. So we're gonna move on. Um, so coding the decision tree, basically need to conceptualize the decision tree accordingly. Because I've actually been having more problems with. There we go. My chat's not working. If I keep saying that we're gonna do it and then I don't do it, we're probably gonna have a problem. By the way, thanks for the sub. I appreciate it. I really do. Every bit helps. Oh no, did I actually do what I think I did? This isn't still going, is it? I'm so sorry I'm taking this time. I'm just gonna click be right back. Holy shit. Been quiet this whole time. I had 2 viewers. Anyways, we're gonna move on. Forget about that blender. So, what was I getting to with this predicate? So with the predicates here, you're taking the predicate, you're giving it the object that you're comparing it with, and you're giving it the variable name. You're also going to be passing over the function. You're not putting brackets around it. You're not going to have to worry about this, that assignment. You don't have to worry about any of that. All that's already done. The compiler is just going to look for whatever um, function that you've labeled as find points, with the exact punctuation, etc. So this predicate find points is now located here, and it's actually passing array.find points and the predicate, which will return a true value if this parameter matches. And once it does that, it's the array.find. It's going to assume that that's the value you were looking for. And that's just one use of a predicate using existing library functions. Another use of predicates would be like, well, the decision tree. We're gonna get into the predicate first. So public, I don't even know. Bool, with that example, the predicate they passed in does take in points object. Oh, because I'm not comparing user style objects. I'll be comparing just whatever data types I can construct. All right. No, maybe I do actually have to pass in an actual object. So I don't want to use the one that I have from school because I don't want to use their work. We're gonna go with a decision tree for something more industrial based because I feel kind of alienating doing anything else. By the way, if you're enjoying our coding coffee session, please give me a like, give me a follow, subscribe, whatever's required. So with this bool, what programs have I already got working? Functions and recursion. And this is what we talked about yesterday, is using this recursive method, which basically calls itself over and over again until we actually do finally get a return value. Okay. So public bool, huh. Let's actually just reuse our hammer objects. Whatever. We're fine with that. Mm. Yeah. Yeah, we're gonna do that one. I'm just gonna do this to remove compiler errors. I don't need these actual functions. Sorry. I'm gonna start recording these classes beforehand. I'm sorry about this. That's not the point of this example right now. All right, so we have hammer wait, and then this over here, and this does not have to be inheriting from the same location. And yeah, okay, I did make it public. Just to keep everything consistent. That's typically what you'd want to do anyways. Okay. So we got these two functions. We're just going to use them as predicates. And just to make sure we're still good. Hello world, and that's all it was called in our main function. That's why it's, yeah, it looks bigger, but it doesn't do anything different. So we can remove this now with confidence, knowing that our compiler is working accordingly. So any errors that we have from here on out are from yours truly. But yeah, we're gonna go ahead. Predicate. Oh shoot. Predicate. Hammer. Brand match equals match on brand. Done. I'm just curious at this. Oh, shoot, too much. Yeah, it didn't like this. So it doesn't like this because it doesn't exist apparently. So we're gonna go with this match on. Will this at least work now? This brand doesn't exist. We'll just go. This is just what I'm putting into root to disable any compiler errors I'm having. Okay, we're gonna go back to our example because this is part of programming anyways, basically learning how to use these. Function predicate find points public private static pool. Okay, so it could just be the fact it's not static. Let's double check that. Public static pool. That was not a problem. Okay, so we're gonna try this again. Match on hammer. I would like to pass a name to it that I can compare it to be honest. Yeah. Okay, so I'm literally looking up how to pass in multiple parameters into a predicate. Tuple. Tuple is a keyword. So we're gonna go ahead and look up what a tuple is, because it's gonna be very helpful. It sounds like. Cool. Huh. Okay. So this guy actually used tuple, and that's not proper. The best answer didn't answer my question. The best answer just said do something else, but I need to use a predicate for this to work properly. And I would like to be able to pass in a comparison value instead of having to store, the concrete, or sorry, a concrete, a constant. That's what it is. It's predicate with an anonymous function call. Predicates with multiple conditions. Hmm. What's multiple conditions? No, I just have one condition. Okay. So we would just use a function keyword. Predicate is not it. passed in this predicate. Yeah, this is nope. This is bothering me. See, didn't have a problem. I was going. Do I have to specify? I shouldn't have to. Oh, yeah, no, 'cause it's a string. And this is program.hammer. Although it's very extensive, it doesn't really help me out as much as I need to. So it appears as though C sharp predicates can only take in one object and create code that's more clean. Predicate is general meaning in general means a statement about something that is either true or false. By the way, I'm getting this from zcode.com. Um, predicate in general meaning a statement about something that is either true or false. In the program, predicates represent a single argument function that return a Boolean value. Predicate in C sharp are implemented delegates. Predicates delegate representation, the method that defines a set of criteria and determines whether the specific object meets the criteria. I think it's got something to do with okay, so I'm gonna have to look up what this tuple keyword is. I just keep throwing it all over the place thinking that that might correct it, that might correct it, that might correct it. Yeah, that's not gonna work either. Heard this a couple times while I was in school. Let's just make sure I understand. Tuple in mathematics is a finite ordered list of elements, and tuple sequence of n elements, whereas where n is a non-negative integer, there is only one zero tuple, referred to as the empty tuple. N tuple is defined inductively using construction of ordered pairs. Okay, so that I got from Wikipedia, but it looks like it's a list. Tuple's just a list. Tuple types. Okay, I'm sure that that should be the way to go. Yeah. Okay. Why do I keep doing this to myself? It's a brand. Ah. Okay. So that's one way we can do it. We can pass through a single tuple object, and the tuple object will take those two on as parameters. Um, yeah, I'm starting to see why we did a lot of our examples in C++. So we're gonna go ahead and do the same thing over here, and then we're gonna test it because I really have no freaking clue uh, if this is gonna work. I'm just playing with stuff at this point. So if you have any questions, by all means, please ask them. It's gonna help me out. It's gonna help you out. Item one, wait. Item two. Yeah, so I guess today we're learning about tuples too, which is basically just a finite ordered list. And then yeah, So because when I specify it, I can specify it with these two properties. It already knows I have an item 1, item 2, and it can access all of the public values within that, which I think is super cool because I'm a nerd, and this really helps me form predicates better. So with that predicate, I can actually take that. I'm gonna go again. Just change this a little bit. Copy, paste, predicate. Um, equals new predicate hammer int, and then I'm gonna go greater than ounces. Shut up. An object and reference is required for non. Oh yeah, of course. Duh. My mistake. So yeah, predicates have to be static. What else am I breaking? That's what I'm breaking. My mistake. Okay. All right. Quick solutions, right? I'm just curious if this fixes it too. Yeah, I think it's fine like that. Because that's how it should have been. That's how it should have been isolated. Like, I don't need that lengthy text. So I have those two predicates, right? I have these two functions here. So now I actually, you know what? I want to test the hammer. So I know it's going to return true or false. I want to test the hammer. I want to test the predicate. Hammer. It's going to be my brand of hammer, sure. Do I have brand and then, wait. Gavin brand. Super reliable. And then we're going to go, we're going to make it a 10-ounce hammer because that's how I roll. I'm a heavy hammer, man. Hmm. After I'm done testing out some stupid things that I thought would work, I'll look back as to how to actually create a tuple. Oh, my bad. So we already know this is Gavin's brand hammer equals my Gavin brand, not Gavin's brand. And then we're gonna go. Oh, okay. Um. Oh, geez. Heavy hammer, not heavy match. What am I doing? I'm missing these little things. Ah. So there is a problem with this. Okay. No. Gonna try some explicit conversion. Okay, so heavy hammer. Is there a library I need to include to make this happen? I'm not sure. I think I already tried this. Cannot convert static type tuple. Oh, it cannot convert to a static type. That makes sense. Okay, what if I... then I should be able to go tuple. No. Syntax is getting closer. Oh, it has to be there then. No, no, it's still the same problem. Cannot implicitly convert predicates program hammer, my hammer into tuple predicates. not going to work, but I'm just taking a shot in the dark here. Unless it's the syntax, I'm wrapping it wrong. I don't know tuples well enough. They seem pretty easy just looking at this, but let's take a look at these assignments. It's just not it's not recognizing it as a tuple. Get rid of that. Get rid of this. What I'll do is I'll just put this back in brackets, hammer. Heavy hammer is the predicate. Hammer to match is not predicates. Oh, I guess technically these are all predicates. System.tuple predicates.program.hammer. Because, yeah, this still has to be converted to a tuple. And it can't just implicitly convert like that. Hmm. Oh. Whoa. Whoa, whoa. What did we have here? Do we have progress with tuples? True. Yes. Yes. Okay, we learned something new today. We learned about finite lists known as tuples. What we can do is we can't convert, but we can generate a brand new tuple and pass it right through. So that will allow us to increase the usability of our predicates, which I couldn't find any examples of anyways. There was some guy on Stack Overflow who was going the right example, but someone misled him. They didn't quite understand what he was trying to do, or he was just saying it's easier to do it this way, but doesn't understand, you know what, I need a predicate object. Okay, so moving forward, yeah, I'm actually gonna go grab some food, go for break after that. That was just too much silence, and I'm sorry about that. But yeah, so what's happening here? We have a predicate, all right, and because predicates can only take in one value, I have to pass in a tuple. What is a tuple? A tuple is just a finite list. A finite list of, in this case, a hammer and an int for this predicate, and any predicate that I want to assign to heavy hammer, and that's just the variable I name this. So I can realistically, as long as the function that I'm trying to assign it to has fulfilled these input variables, this input, a single tuple, and it'll work. And then I basically just, and this is why it wouldn't work so well in C++, and we have different tools, pointers, and stuff like that, is because anytime because a predicate, that's what it is. That makes a bit more sense. In C++, a predicate's more or less a function pointer. But anyways, I would just convert it to a brand new tuple, which is a pointer, essentially, in terms of what C# would recognize. Yeah, just a little bit of extra knowledge for you. You don't need to know that, but it does help occasionally to understand, okay, so this is a pointer. So yeah, we're going to go ahead and actually, before I do that, let me just. Obviously, a super reliable brand. Very intelligently crafted. There. The reason why I'm changing this is so that we can see if the predicate's going to fail as well. And this, so the top one should be true because I'm console writing that out. This evaluates and gets assigned to V, but then I print it out afterwards, just so we understand the order of operations of what's actually happening here. I'll adjust this and make it look cleaner before I upload anything of this. But yeah, as we can see, we have true evaluation, and then this hammer is not heavier than 11, so this is a false evaluation. We have true and false. So our predicates are functioning exactly as they're programmed to. I couldn't use them as well as what I'd like to, but I think it's because predicates are more of a C++ thing. But it's still going to help us out when we come to coding our decision tree, because with the predicates, we actually be able to store predicates in the nodes. So you see, the assessment, what it needs to be assessed on, will already be there. All right. We're going to go for break. If you have any questions or concerns, or just want to know anything else a little bit more in depth, please post a comment. I will check them when I come back. Thank you so much. We'll be right back after a short break. Thank you so much for patiently waiting. We are back. Thank you for joining us. I was actually just thinking about something that we're missing. Something that would actually improve the usability of our decision tree immensely. And it's the let's go into functions of recursion. Let's go back to the decision tree. And that would be templates. And I just feel as though if we had templates, we'd be able to pass in templated predicates. And I'm gonna look into this as we go along. Templated predicates. So that way, when we code our decision tree, as we as we're attaching nodes into the tree, we could attach different predicates because the not string. Let's go. Tuple. And then we are comparing what I do. We'll have a decision tree for my hammers, sure, because I already have that coded, and that's going to be easier for me to just port over. Hammer and I'm gonna put. Can I? I'm just curious. Let me just double check this. I'm just gonna quickly search template in the C# docs. I'm a C++ programmer. I understand object orientation. Usually concepts are easy to um, wrap your head around using C#, so that's why I program using that. But we go template. Template C#. I didn't do C#. Google fail. Generic methods. I've used this one before, so I have used. Okay. Okay. Oh. This just got easier. Maybe. T could not be found. Okay. So is there a library reference in this? For using templated functions? Nope, nothing there. Hmm. I was really hoping that we could do that. If we could pass through a predicate template. I look through, so yeah, sorry about that. I'm just double checking here with this. This is essentially what I'm using. I'm going based off of that. And I'm actually gonna test that specifically to make sure that there's no real, that I'm not missing anything. Main, so I can do this. It's a function within the program class. Static void swap. Put the template indicator there. Yeah, that seems to work. So I don't think we'll be able to. Whoops. Yeah, we're not going to be able to run a templated. Let me literally search templated. I feel like that should be a thing. And it predicates are pointers. Predicates are pointers. They just don't look it in C#. C++, it's a lot more apparent that you see them as function pointers. But the oh, by the way, the guy I follow, Snackpack G, is on playing Fortnite. Just figured I'd give him a shout out because he gave me a shout out. Anyways, yeah. So the way predicates work is they're pointers. They're pointers in the virtual space, which point to the function itself. So to have a templated predicate shouldn't be so difficult considering the basically the absolute base class is gonna be so variant. You should be able to. So I'm gonna look that up. Don't mind the lunch. Yep. I think I have to define the predicate. I can't just template it. Yep. Yeah, because T, it seems as though it's a reserved class. Okay, so we're gonna have to do, what were those called again? The finite lists tuple. I didn't even find it, but can I do that? Yeah, you know what? It's because I don't have a type for it yet. It's not supposed to exist yet, and I can't do pointers. I gotta find out what exactly I need to do for that. Still. That's why it's declared. Okay, I'm gonna look back to the predicates because provide predicate in there. What? Wow. I can tell the other guy wasn't having it. I had 2 viewers for a second, and he must have seen that I didn't have that there, and I was still looking all over the place. He's like, "This guy don't know anything." Left. Like, okay. 'Cause my eyes ain't what they used to be. Alright. Simple enough, right? So we've assigned our predicates, and these we're gonna change later. I'm just kind of doing that for fun. So now our nodes contain um a left and a right direction, which actually we're gonna create these as null right off the hop, because I understand if we're just passing it a predicate, it's at the very bottom of this tree, and the pointers aren't gonna point to anything. So there's that. I might have to go double check the C sharp example to make sure I get this right, because I just there's a difference between passing by copy and passing by reference, and I want to make sure I pass everything by reference, and copies I just don't care about. Um, the reason why is because if it's a copy, it's just going to be a brand new representation, and then by the time that part executes, it's done anyways. So it's not like I'll need. Chances are I won't need that data for anything else. Um, but if it's a reference, that means that I have to maintain integrity with that specific value. So when I do pass it through, any alterations to that within a void function actually happen and then continue on through. So oh, they did, yeah, okay. Well, their example's different. That's all. But it is basically the same stuff. Yeah, public decision. I'm using public node. I'm not using public values either. Oh, that's why. Huh. Yeah, they're doing the evaluation per node. Um, I guess that's actually probably the most efficient way to do it. Um, I was just gonna run a while loop. Uh, I like that, but that's gonna be more complicated, so I'm just gonna do it very simplistic. So we have within this node, these are pointers. Just consider them as pointers. Um, left PTR, right PTR, and so it's literally just pointing to another node. Um, we're done from there. Decision tree. Decision tree is going to contain all of the nodes. Decision tree is going to also contain um, the links to each new node as well as the predicates for it. So when you're creating your decision tree, as you're creating each object within your decision tree, you're going to want to start from the bottom where it has no nodes to attach to thereafter. You're going to want to start from your absolute resolved um, stand and then just kind of move your way up because you won't be able to connect variables that don't exist. So, um, we had a good one. It was just for cancer. And we had legitimate statistics to base this off. So it was a lot easier for me to come up with an example. This worked. I'm going to get rid of this because now I know how templated functions work in C sharp. Um, this is the main. So this is what's going to get called decision tree. So we're going to go hammer. We're assessing for hammer. We're going to bring our hammers back. Sure. All right. Now that I've got my hammer back, I'm going to go ahead and go that can work. Yeah, because what I can do, and this is just to make sure the functionality stays the same, instead of being able to pass a type reference, we're just going to pass in a string number representation and then convert it. But this is kind of like something to keep in mind as you're making your predicates. So we made the predicates and then we assigned the predicates to the predicate to the function pointer. Go back to using that term. Um, that's a little backwards. What you probably want to do is create the object that's going to contain the predicate, understand how that object needs the data in order to operate with it, and then you can create the predicates using that. It'll just you'll have a lot less refactoring involved. For instance, you've seen what happened when I realized I couldn't put more than one value, so I just used a tuple finite list to pass into the predicate. And what? Oh, computers always make sense. It tells you there's something wrong. There's something wrong. That's all there is to it. Same thing. Hammer. Okay. So we're gonna compare it with a string value. Um, and knowing that that's the route that we have to go, we'll be able to write it for that. So go public. Oh, it has to be static. Cool. I don't want to order it. Oh, I'm sorry. I'm having a really hard time trying to come up with the variable decision tree for a hammer. To swing or not to swing? That is the question. Uh, I don't even know. We're just gonna call this like cred one. For now, I'll fill it in afterwards. Um, so I know I have to take in the hammer and string, hammer, hammer, string. Um, sure. Oh, so you won't let me do it there, but you've let me do it before. Or I'm not. I don't need to worry about this. This is just item one and item two, anyways. Got like 15 items in this tuple. Maybe I'd be a little bit more irritated with it. But yeah, because the functionality is going to depend on this. You know what? I'm going to go. You know what? We'll make this a classification tree. It's the same idea because basically instead of like the actual choices that I'm pumping in, I'm actually just putting in. I'm just gonna put in parameters to be able to classify different hammers. So what we'll do is we'll start off by looking at well, different hammers, because as a programmer you should have some kind of insight as to the kind of programs you're building. And we got all sorts of different styles of hammers, it looks like, and I'm probably gonna have to add a couple of things to this list to make this workable. But we could go. I'm gonna go by like hammer weights, because I do want to classify by a hammer weight. So I already got that. You know what? What? Oh, okay. Weird. No, I gave me the weight value of the hammer guy from Mario. Hammer working weight. You know what? I like the first hammer classification where it had just way too many crap that we had to go through. So, the code here it is. Brand weight. There we go. because basically, yeah, with this hammer, I want it to simulate your average, ordinary, everyday um, framing hammer. Uh, Rounded brick hammer uses stone hammer flat face. There's a couple hammers that have a chisel. Okay. I'm not gonna care about classifying that. I'm just, I'm gonna just get into this. So between nearly 2 feet of heads up to 20 pounds in weight. 20 pounds in ounces. I don't know. Sledgehammers starting weight. Okay, so I'm just gonna classify that as if it's 10 pounds or more. Um, there we go. So I do know that if it's got more than 160 ounces on it, it's probably going to be a sledgehammer. So that's going to help me with my decision tree, and it comes to isolating that one. So we got has claw, has chisel. Tack hammer doesn't seem to have either, so that's a good classification. We're going to go ball peen has a rounded side, no chisel, no claw. It has lower weight than 160, so we can classify that. A brick hammer has a chisel, doesn't have a claw. It doesn't look like. Yeah, the chisel is the claw. And the There we go. And the brick hammer has a chisel. It doesn't really have a claw, but it has a hammering surface. A claw hammer, which is your standardized hammer, it has a claw. Um, no framing hammer, I guess. Sorry, it has a claw. Oh no, this is gonna be an issue. So between 16 and 22 ounces and has a claw so far. That's the okay. Mostly all hammers are going to have smooth faces, right? Except for the claw hammer, which apparently has a rougher face for more accuracy. All right, drywall hammer. It has a chisel. I'm calling it a chisel. They refer to it more like a hatchet shape, but I'm calling that a chisel. Um, it doesn't have a rounded backside. It doesn't have a claw. It does have a smooth face, so it has a smooth face and a chisel, and it has a weight between 16 and 32 ounces. So we're going to be able to determine that. An electrician hammer. Okay. All right. So I just had to create some kind of separation between electrician hammer and your standard claw hammer. Framing hammer is a specialty claw hammer. It's twice as heavy as a standard claw hammer. So standard hammer is actually a claw hammer. I just ended up getting framing. Our milled face. So it has a waffled striking surface. So like the claw hammer. Oh shoot. It has a claw like the framing hammer. It'll be between 16 and 32 ounces like the framing hammer. Oh shoot. Say like the claw hammer. I don't think I'm gonna specify between that two. I'm just gonna call them both claw hammers. But yeah, I'll still keep the rest of that. Sledgehammer, tack hammer, trim hammer. Really lightweight. So what we'll do is, yeah. So we'll start off by weight classification. Uh, and what I'd like to do is basically send them if they're heavier. We could probably run this assessment right away. Um, because it seems as though a lot of the hammer classifications revolve around weight, size for their use. So we're gonna go public bool is a um, what the heck's it called? Trim hammer. And this just immediately will exit the tree. So we'll go items dot oh no, this is actually sorry. Because I'm passing in two values, I'm able to do that. Items dot item one dot weight greater than equal to. I'll just do greater than. And then we're actually gonna call this int dot int So a decision tree is literally just a series of small evaluations. What are you doing? Does not contain a definition for item 2. There's no accessible method. What do you mean? Okay. That'll happen. I think the compiler just took a little bit of time to catch up. So now, instead of creating a vast amount of weight checks for sledge, tack, and like somewhere in between, I'm just going to do a weight check method. And what I'll be able to do in here, my decision tree, I'm not doing this. I'm not really starting at a terminal node. So I don't think I want to use that one right away. So, but this I'll be able to use up to 3 times because I'll basically be passing a string in with the hammer. And because I'm using a predicate, I can swap that out later. So if I am actually just checking true or false, public static bool I don't know if this is going to be as easy. Nope. No, it's not going to be as easily done. It's not going to be as universal. So what I'm doing here is instead of I should probably keep that the same. So uh, let's go bool bool b equals I so this bool equals the items dot item 2 equal true, otherwise it's false. Oops. That's why we have that condition. Then we go return items dot item 1 dot is rounded equaled so this I'm basically going to repeat a whole bunch of times. I know what you're thinking. Well, I'm sure there's an easier way to do it than string and then converting it. There is. This is like lazy programming. Borderline. I wanted to be able to utilize the exact same constructor and predicate here. So for me to facilitate that, I have to fulfill this promise over and over again. I can't type name it, otherwise I would have just type named it, but it's not yeah, that's not working. So round check, we'll check for the roundness. Then we have chisel check. And then we'll have claw check. And as chisel, as claw, go ahead, copy this, paste, smooth and conductive. Excuse me. All right. So for the terminal nodes, we'd have to think about what is going to be the final answers. Like, I know for you know what? Because trim hammer, this one's fine because it's like it is a terminal node when it comes to the weight. Um, okay, so like I think the best way for me to do this is the root node is also going to be a terminal node in this case. Uh, okay, and then how do I? This is better. Yep. So we have to do some conversion because it won't implicitly convert. Oh, forgot to. Almost had to figure it out. Oh, geez. Um, node root. Oh, Seriously? I guess because it is no, it's converting. Yeah, I was gonna say, um, I have to use it similar to a function called, don't I? Root equals new node. And then my issue with this is actually probably public issue. Done. Sorry about that. Yeah. Okay. Thanks. So we have the root node. So the root node's actually going to have multiple nodes pointing to it. I don't want, so you never really want to start off with a node. You want to start off with the terminal one. But the root node is actually going to be a terminal node. So what I think we need to do is go through here, public, copy this, drop another reference here, and instead, oh no, actually, we'll do it like this. Uh, Public void set um left node left left equals really left. Do the same thing, but change it all to right. And this is going to allow me to set either which one I feel like doing. I think there was another parameter I had to click for that to work properly. My bad. So we go set right. So right and left are now being set officially. Able to be set officially without having to add any extra parameters on there. So yeah. Node. What should one of the terminal nodes be? So basically, if we think about how this is supposed to activate, let's actually pull up our Word document or text document of some kind. So we're going to go here, and then we're going to go, you can't see that. That's why I'm doing that assessment first, because it's just going to stop the whole tree right away. This one I'm going to make public because I'm going to reference it right away. I got to do the same thing over here. It's basically just the title of the node. We can keep these assessed to null, and I think the absolute terminal nodes will be the decision. So let's just do that then. Um, there we go, title equals title. So this will allow me to construct a node with just a title, which will be the decision, the absolute terminal decision. This will allow me to create a node with a decider. This isn't even necessary. Well, it might be. Yeah, it is necessary. And the only reason why I'm saying it's necessary now is because there's going to be terminal nodes where there's not an assignment on the right, or there's not an assignment on the left. So yeah, we'll stick with this, wait, check, and then we'll go node, um, terminal trim equals new node, take in trim hammer. Okay, you got a problem with that too? What? That's what you got a problem with. It's not even, it's not me. What other hammers do we have? So we have terminal trim, terminal tack, tack hammer. Not gonna bother with the framing hammer. They're just all gonna be claw hammers. Shoot. Yeah, a lot of typing on these. Yet typing the same thing too many times. Okay. So being that we already know that trim is we already have all of our terminal nodes set up. All these nodes are going to tell us at the end of the decision tree when the hammer is finished getting classified what hammer it was, given the logic that we're going to program right now. So all these nodes are terminal nodes, so they don't have a left or right. They're null. And it has no predicate. It doesn't need one. No assessment. No assessment required. So the function pointer is null. The node pointers are both null on these, and what we're going to do is we're actually going to go node. Better not do that one yet. It's funny because that's the only thing I can think of right now. So weight of hammer less than 16 is a trim hammer. That's what we're gonna, and then after that, it's gonna go through other assessments. So if the weight of the hammer that's going to lead to more options. So if it's between 16 and 32 ounces, it's going to be a majority of the hammers. So I think what we'll do with that, that's going to lead into another assessment, where we're going to assess for other hammer particulars, such as if it's rounded, it's going to be a ball peen. If it has a chisel, and a smooth face, it's probably a brick hammer. If it's, oh no, this has a smooth face. Has a chisel. That's wood. These classifications suck. But the point is, I'm gonna get the point working either way. This is not a good good analogy because there's just so much. Okay. Has chisel. I don't want to add another. Shoot. Okay, I'm not going to bother with the drywall hammer then. We're going to remove that node. And we're just going to assume, I know they're wood handles, we're just going to assume they're all conductive because this electrician hammer right here, it's fiberglass insulated and rubber handled. It's legitimately not conductive. And fabricated to be so. So we're just going to keep that classification. We're going to get rid of one of the hammers here. Yeah, so new node. Decision. I'm just going to call it decider. Last. My node options here. We're looking at predicate and a title. Left, right, and a title. So terminal decider. This is going to be the difference between Pretty much any of the hammers that weigh between 16 and 32 ounces. That's gonna be the better way to go about it because then it's gonna come back negative. Um, it depends on the location, I guess. Okay, so terminal decider for ball peen, brick, claw, electrical, tack. Ball peen is rounded. Oh, yeah, that's right. I could keep the drywall hammer there. Oh no. I'm basing that off of it's saying it's got a peen-like head. So the peen is the rounded. Tack hammer. Oh, okay. Okay. So these are what I'm gonna classify each one. That's just basically how I'm gonna be able to word each terminal decider. Um, so it looks as though the first node I'm gonna hit is gonna be checking the weight, and if the weight is less than you know what? I'm gonna start on that side because if the weight is less than 16, it's gonna lead to claw or no claw. So we're gonna go with this node right here, predicate. Um, the predicate that we're gonna insert. Oh, left, right, and then predicate. Yeah. So left is going to be um terminal. Let's go left. It doesn't really matter. Trim. Sorry about this. Oh, okay, this might actually have to be. Yeah. This isn't where we tested our predicate earlier, is it? No, this is. I'm just, yeah. I should have just kept typing. Anyways, so it's already going to have all the terminal nodes, and then within the constructor, I'm going to go ahead and go. You can kind of see where I'm about to go with this, though. The way I look at it, the weight is going to be the decider for a lot of these. Sorry, not the decider, but the classifier we're actually adding, believe it or not. Um, because the light decider right here, this is going to be a node attached to the root node. So I can't really make the root yet because I have to figure out the root node is going to be, actually here, let me just make that in an extra line here. Node. It's because I'm naming everything with capitals by the looks of it. Root node. Where I'm going to be able to go. Which one's supposed to be here? Left, right. Okay, so if it goes left, I want it to go towards something I don't have yet. I'm just going to go. That's just for a placeholder. And then what I'd have to do is, yeah, weight check. I may have messed this up. I guess I'll find out. Root node. Just gonna call it root. There, now you can see it all. Okay, so claw hammer. So if it's between 16 and 32, we can immediately go for conduction. And then that's going to be a 4 terminal node too. So we can actually put that one in now. I'm going to get it. Okay. Terminal conductive decider. Oh, shoot. Claw check. Okay. So positive, I want it to go right. That's left too. I don't know. Positive, I want to go right. Negative, I want to go left. So I got a claw check. If it's got a claw, left is negative. Right is positive. So if it's got a claw, then it's a trim hammer. So it's going to go towards the terminal trim. If it's oh, I guess this is close to a terminal, but it's not quite there yet, so we can't work on that one yet. So I'd ask that question, sure, but that's not totally terminal, so I'm going to do something different. Is conductive, so if it's not conductive, then it's either chisel or claw, chisel or claw, rounded or smooth face. So if it has a chisel, it's not going to have a claw. So conductive, no. Has chisel? If the answer is no on that, I think it is rounded. that might be it. Okay, so I'll go. So you'll notice I'm putting decider in front of the nodes that are next to the terminals. Whoops, node. So if it is round at this point, you can see here. This is as if it doesn't have a chisel and it's round. So it's got a claw, or nothing, and it's rounded. So yeah, that means it's going to be a ball. So if this is positive, negative, round, it's got to be, where is it? Oh, Jesus. Sorry about that. Okay. So if it has a chisel, so if it doesn't have a chisel and it's round, it's a ball peen. If it doesn't have a chisel, right here has claw and smooth face, and it's not rounded, it's going to be a terminal claw. Um, okay. So is leading into terminals. All right. So we can back up from there because there's a both terminals. We're gonna go to has chisels, so the is rounded. Um, pre-decider, chisel. So if it doesn't have a chisel, it's gonna go to terminal round decider. If it does have a chisel, and it's conductive, it don't matter. So at this point, it has a chisel. It's between 16 and 32 ounces. And it is conductive. So I know I'm not, this factor will not be making it an electrician hammer. So has chisel is conductive. Chisel, brick hammer, Oh, okay. So this is a terminal as well, a terminal decider. Because it's gonna go right to the drywall. Yeah. So if I look back at this, is conductive is also a terminal. So I can go node conductor. Node new, and if it's false, it's gonna go to pre-decider chisel, which I'm gonna rename. Terminal chisel decider. Terminal electrician. Conductive check. And just for demonstration purposes, I'm just going to assume all other hammers are non-conduct or are conductive. Um, it's wrong. It's going to go terminal conductive decider if it's right. Terminal sledge. Weight check. Oh wait, no, because I'm gonna have this come back false. Weight check. If the weight is greater than the number I passed through. If it's greater than, then this is negative. So this number is greater than. Okay, so it'll be positive. So that's positive. Um, that means that the weight's less than it'll be. Okay, so the conductive side terminal sledge, and then I think this is where. Whoops. Yeah, just put that back there. This is where I would want to put. Let's get rid of this. Node. I'm just gonna call this pre-terminal weight equals new node. If it's negative, so if it comes back and it's less than 16, no, if it comes back and it's greater than 16, it's gonna go towards terminal weight decider. Whereas if it's positive, light decider, weight check. I'm gonna be right back. I gotta run to the restroom. I'm gonna finish typing this right out. Is this a light hammer? Oh, let's see, 16. 16. Less than 16. Be true. So is this a light hammer? Yep. Actually, I think that's the, I'll call this root. Because that's what it is. It's the root. It's where it all stems from. Let me just make sure we got claw, terminal ball. We just don't have terminal brick. Chisel and smooth face. Okay. I might just get rid of the brick hammer just for this demonstration. Chisel and smooth face, less than 32. So if it's less than 32, it's going to go over here to the conductivity checker. If it's conductive, it's going to head over here to the chisel check. Round decider. Oh. So if it's round and it's positive, it's going to go over here. Otherwise, it's going to go over here. Between claw and ball? Okay. So if it's a claw check and it assesses negative, it's going to go terminal brick. Whoops. Otherwise, claw. Claw check. Okay, so now that I've added all these nodes, and I'm just going to program it in the tree. Public, decide. Okay, I'm fixing this up completely. Okay. Oh, I might I'm probably gonna play with this right until the end of the, 'cause I think I messed up right at the beginning here. And that's right here when I assign the predicate and I'm trying to pass in 2 variables to the predicate, and then I give the predicate tuple. Mm, here, let's just oh, okay, so you have to assign the object that you're assessing to the node for this to actually work. For some reason, I was just thinking that, yeah. Anyways. Um, side yeah, so it's not gonna let me do that. Hammer dot node. What do I call it? Yeah, it's just predicate. Yeah, so I will have to change this around. Each node is gonna hold on to whatever it is I'm returning. So I'm actually gonna go predicate that takes in a hammer. just so you guys know, like this is a total assignment that I've had in the past that I had like 2 weeks to complete, 3 weeks to complete. I'm trying to do this in a matter of hours. Okay, so this is all working out, looking like it's gonna work now. And then I really only put these up in case I needed. I don't even need these. They're not being referenced at all. You see the 0 references right there is telling me that I can delete them. It's not going to have an effect on the program at all. I might want them later though. We'll see. I know. Sludge is a. Looking to see the specific overload. Okay. Left is negative. So sludge is a positive response. Um, I wanted to make it super versatile. It's not going to happen. Oh, this can go away. That didn't happen. Why am I bothering with that? These are all Boolean values. All right, we're gonna go for break for just a brief moment. And we're back. Thank you so much for being so patient. Go to iteration. All right, thank you for returning. We got same stuff. Haven't really done anything. Paste, and then I'm gonna return this. Why do I do that? Oh no, because it's not a factor of the hammer. It's within here. The node. Okay, so we're gonna go hammer dot terminal node dot I don't care enough. Just gonna make that everything all public. Predicate bracket hammer if bracket hammer dot terminal node and I'm just gonna write this other function here. As options return yeah. All right. So what we can do is we can kind of decide here what we want to organize. hammer equals new hammer. And we're going to use a default constructor. Hammer my hammer2 equals new hammer, but this time we're actually going to give it some value. Yeah, I closed it. Bool, rounded, bool, chisel, bool, claw, bool, smooth, bool, conductive. Oh, come on. Smarter than this. I'm smarter than this. I almost had to yeah, change that across the board. I realize I'm already assessing that. I don't know what I just did, but I'm gonna undo that. Remove it. No. There. That's just a common practice I have. I tend to put those tags at the end of my objects. Thank you. And then terminal node, where are you? You're in the hammer class. This is always going to equal null to start. And this question mark, all this question mark does is it tells the compiler it can't expect a null value. What that means, like I said before, with C# being very high level language, you don't really see the pointers, and it mainly just works with pointers. Um, not predicate. Oh, I know the issue here. Okay, so we're gonna go ahead and say public void sign node node uh, node equals, whoops, oh, it's root node. Terminal, my mistake. Okay. So sign node. So decide. What? How come I can't pass it the root node? There we go. This side, root node. And then so now I'm actually entering a Husky 45 ounce sledge. And I spelled Milwaukee. A, probably. And now we're gonna add something like this, a Milwaukee electrical. Put all my classification down here. Okay, I need to do something. There. Open that up. I just need this on my second monitor while I'm writing the classifications because I'm looking for I'm expecting an answer. And basically this here is all of my pseudocoded logic. And then my actual hard code logic would be within those predicates. So Milwaukee, probably do this too. What? Oh shoot! You can only do one at a time. Guess it makes sense because it's in a buffer. Okay, well, let's do it like this. Oh, you're not going to be that easy, are you? Of course not. Just gonna keep this. All right, so with that, we have my hammer, and then weight, rounded, chisel, claw, smooth, conductive. Rounded, chisel, claw. No. Rounded, chisel, claw, smooth. Yeah, okay. Want to have an electrical hammer. It's just going to be non-conductive. Lesson. So we'll go 16. Seems to be a standard. Rounded? I don't think it is rounded. And then we're going to go. I don't even know. It doesn't. The brand doesn't matter. We're gonna go. Yeah. Okay. You guys will get a kick out of this. Ryobi? Ryobi? That's how you spell Ryobi? I don't know. I haven't bought it in so long. Weight. We want this to be 22. We're trying to find another classification. We'll try to make this a drywall hammer. So rounded, false. Oh, true. Chisel, true. Claw, false. Smooth. True. And conductive, false. No, wait, true. And let's make sure we get the claw one too, because that's the typical hammer. 5 equals new hammer. Jeez, come on. I can think of a couple more tool brands. How did I miss that one? Make kind of a hefty hammer. Wait, no, yeah, we'll make it rather heavier. This is just your standard claw hammer, so we're gonna go rounded, false, chisel, false, claw, true, smooth, sure, true, conductive, false, true. Everything's gonna be conductive except for the electrician hammer, just so our logic works. Decision tree. So this is all in the main, and this is all I'd have to do. Tree dot decide my hammer. And I'm just gonna go ahead. What I'll do when I actually write this out, I'll make it more eloquent. See if it works. Okay, we are in an infinite loop somewhere. Well, if I just check out the return value from that. Oh, shoot. I guess I should have actually. So if it's positive, we wanted it to go right, right? Oh, I don't have those public. If it's true, we want it to go right. Otherwise, we want it to go left. Evaluate it. All right, because I wasn't actually changing the direction. That was the problem there. Oh, I got a couple of tack hammers. So, all right, my logic isn't working, but you can see kind of the logic that's actually occurring here. And I can correct that. That's the whole point of this object orientation is I understand, okay, so it's just one of these predicates that is assessing improperly. So I can go through here and say which one is deciding improperly. I didn't actually make these parameters, something particular, but this one should be claw, sledge. I got a tack on one of these, so I'm pretty certain that something's off because these are all over 16 inches or 16 ounces. Electrical. What did I put in here? I'm not gonna actually have to end it to do it. Okay, I'm gonna be like that. It's not a problem. Rounded, chisel, or rounded, chisel, no claw, smooth, and conductive. As chisel is smooth. So rounded is true. Okay, so this is supposed to be a drywall. I can double check the replay to make sure that I'm actually he's right, but I'm pretty sure it's something like that. And then the DeWalt was supposed to be it's a 30 ounce, it's a bigger boy. We're gonna go false, so it's not rounded. It's not chiseled. It's got a claw and it's smooth and it's conductive. Less than 32, so it's got a claw. It's smooth and it's less than 32, so this is supposed to be. Was that supposed to be a claw hammer? Why would I do it twice? I'm gonna do ball peen. Just not even gonna bother. I just want to see. You got 2 tacks and a trim. This is one with the claw. So my lightweight hammer, lightweight's assessing improperly. Oh, yeah, less than. That makes more sense. Oh, I'll get 2 electrical hammers, but they're both false. Left is wrong. Right. Right is right. My conductive check. Oh, it's not conductive. There we go. There's some fixed logic. Actually, I think that's exactly what I wanted now. So we fixed our logic. And essentially, yeah, we can. I'm gonna follow through step by step so we have it on the recording. But basically, what's happening is I've literally composed a freaking. I've made one of these. All right. And then what I've done is I've said, okay, this node right here, this is where everything's going to start. That's why over here, when I run my decide function, it just assigns the hammer a node, the very first root node right there. So that the hammer sits here, all right, and then it while the terminal node still has options. So basically, while the two strands aren't pointing to things, it's gonna keep running the function within the predicate and passing itself that function. And hammer terminal node equals. So basically, this is where I'm just reassigning the node that the hammer is representing. Um, that would be the deciding factors, right? So at first, it starts off where this node is the root node, and then it goes through and it says, okay, we're gonna find the predicate that we stored in here, and if it's positive, it goes this way. No, that's left. If it's positive, it goes this way. If it's negative, it goes this way. And then from this node that the hammer goes to, it's like, oh, okay, let me assess it here. And if it's positive, it's going to go this way. If it's negative, it's going to go this way. So it's I've literally constructed an object. Um, I don't need that. And right here, basically, I just made these. I assigned them in the first place just so I'd be able to assign them elsewhere instead of having. I don't know why. In the constructor, I have to have all my objects instantiated. So it does kind of look weird. And that is, I think, the C sharp difference. That's probably why we did everything in C++. But anyways, as you can see here, these are the actual delegations, and these I named them terminals because that's at the very bottom of the tree. I threw it away. And then you'll see right here the decider are the ones that go right before it. And I didn't really have anything like too intricate where it's webbing down and down and down. So I didn't need a whole lot of extra nodes, like the decider nodes, everything led towards something, right? Uh yeah, the root node is the only node that's actually taking it to two deciders. And that's just because of how complicated this binary tree is. It's not really all too complicated. I tried to simplify it even more than what it could have been, just so I can make sure I get the right hammer classifications. But as you can see, yeah, um, where was I naming it? So claw, sledge, electrical, drywall, and this one was supposed to be false. These are my answers up here. So if I click on hammer, it's going to tell me in string brand and weight. So it's not round, all right. It's not chiseled. It's got a claw. It's smooth and it's conductive. It's got a claw. It's smooth. It's conductive and it's less than 32. Less than 32. All right. It's got a claw and a smooth face. Huh. I think that might have actually I put in 2 claws by mistake. Yeah. Oh, the first one counted as a trim hammer. That's right, because no, that was stupid of me. Oops. What is get away from here. Oh, yeah. Yeah. I went to a totally different oh, jeez. Okay, wrong program. Alright. Yeah, because the trim hammer itself let's go here. This is yeah, that is the default. It is a trim hammer. I didn't put this up to 16, so that's on me. But yeah, no, so the logic it's correcting me. Um, but yeah, what I'll do is I'll make it so that I'll write a function so that when it's doing the decide feature, each time it changes a node, it's gonna output the question it's gonna ask as well as the answer it provides. True, false, because you're really only looking for one or the other with a binary tree. And as you can see after it's been coded, the way that we utilize this, and it was probably a little bit easier to understand the functionality then because we had lots and lots and lots of data to iterate through. Lots of it. So basically, yeah, if you were to look at all the factors, you could sure you could tell the probability of dying from breast cancer using those statistics, sure, but you'd be there for hours. You'd be there for days, months, years, probably if you're going through like every single entry. What this does is it allows us to condense it all in an XML. We can iterate through using some of the functions that we talked about. Was it last couple days ago, anyways, with regards to the file handling, and run it through the decision tree. It'll spit out the answers for us. So that's why we would code a decision tree. I actually didn't expect. I know I spent like forever on that. But that was our algorithm afternoons algorithm. We finished our coffee coding relatively early, and I knew that this was going to be a bit of a challenge because I haven't seen this for like 2 semesters. Got it to work, so that's not bad. And yeah, no, I will finish notating this. I need that. I shouldn't need that. Yeah, I am using program. I don't even need using system. What am I talking about? There, done. Maybe I need using system. No, I don't need using system. It's all okay. Cool. Um, that makes sense. Cool. So now that we've done that, I can actually go back and we can go through this sort stuff. I made this all look nice and pretty now, right? So this basically just has to be finished notating, and I have to go through each sort to explain to show that I understand it myself. But I'll go through and I'll explain everything to you guys exactly how the heap sort's the only one I'm thinking I might have a hard time understanding. The I know it's a selection sort, so basically it only picks out the objects it needs to move around. In terms of the swaps happening, I just have to look that over again. But I'm gonna say the same thing with the merge sort. So the merge sort generates a copy of what it's trying to sort out, and as it's going through each value in the array, it just kind of says, "Are you lower than this one? Okay, you can go here. Are you lower than this one? Okay, you can go here." And it just kind of picks out each one. And what you do is you basically through recursion, you continue to split the array down until it's less it can't possibly contain any more than 2 values, and then you write then you copy those 2 in, one whichever one's gonna be lower, you'd put that one first, and then follows the second one, and then when it runs it again, it's gonna run it from the opposite side. No, wait, hold on, let me think. When it runs it again, Yeah, because then it starts from the high counter. That's right. So when it runs it again, it does it on this side, pairs those two, puts them in the correct destination, and then merges it back in. And it just repeatedly does that until everything has been separated and then merged in accordingly. The quick sort, quick sort was my bread and butter. I managed to do this a couple times without needing pseudocode. This time I mean, it's been a little while since I've had to write my own sort function, but yeah, it certainly helped. Broaden the understanding, but it's basically with this, it swaps with each pass. Uh, so like we talked about the bubble sort. I can throw the bubble sort in here too. And you know what? Yeah, I'm gonna finish this a little bit more, and I'm gonna do some wacky programming stuff that's gonna demonstrate the time differences between sorting the array values. For that, I'm gonna have to increase this to like 1,000 for you to notice a big difference, and so I'm not gonna be outputting the values. Or if I do it, basically I'll just compartmentalize it so I'm using it again with a different thing, and then I'll show the time differences beneath it. It'll make sense. It'll be worth the $5 monthly subscription to be able to get this code. Um, that I'm gonna make. What day is it today? It's Wednesday. Thursday I start regen gaming at 8 p.m. We're gonna be continuing the level 1 Elden Ring challenge. We're still at the draconic tree sentinel. Not too bad progress. The first 2 days we got 2 bosses killed each day, so it's just the last day I'm having a hard time with his patterns. But anyways, yeah, with the first, I should have it uploaded. I want to say before the end of Thursday. I want to have sorts uploaded. I want to, but I will definitely have. Yeah, actually, I'm surprised I didn't. I took out one of these things to make it easier to upload for you guys on my Patreon. Right here. This will be uploaded like right shortly. I literally just have to comment a couple more things in terms of limits, and that's relatively easy for me to analyze. Anyways, thank you so much for showing up. I'm gonna cut today's stream a little bit early again. I'm just running low on algorithms to kind of go through. We could start doing searching algorithms. Tomorrow is Thursday. I am hosting one more lecture. I'm gonna have something a lot more planned, prepared, and I do appreciate you guys showing up. Thanks so much, and you have yourself a great night. I'm going to raid out because that's the kind of guy I am. No, not a BRB. I don't want to be right back. Ending. There we go. Sorry about that. All right, and can I get a band to play me out? Have a great night. Thank you so much for joining. We are actually going to raid A Bay Bay. All right, Twitch.